Hey guys, welcome to your final flip lesson for Unit 6. Today we're actually going to review a topic that you guys had covered back in algebra. I know it's been a while since you've seen it. We're going to talk about solving quadratic linear systems, both algebraically and graphically. Now, when we talk about quadratic linear systems, the name basically says it all. We are talking about finding where a parabola and a line intersect, and thus the name of our quadratic linear system. We're looking at where these two objects intersect. When we do so algebraically, we're finding those points of intersection directly without the visual aid. So to do that, our steps are pretty straightforward. First thing we're going to do is make sure that we get both equations into their standard form, or y equals form. Once they are in that form, we're able to then set them equal to one another and then solve the quadratic equation that remains. Now, what's nice about these is you're never going to have to worry about this new quadratic equation being unfactorable. They will always, always, always be factorable since we are finding points of intersection. And that's a nice thing to know. So we're going to use whatever skills are necessary to factor, solve for x, but then we're not done. We still have to go back and find the y value for our point. So remember, these are points that we are trying to find, and in doing so, we need both an x value and a y value for each. So to show you what I mean, let's look at this example here. All right. Clearly, we see our quadratic since we have our x squared term, and we clearly see our line not in standard form. So with this said, we're going to leave the quadratic or the parabola as it is, and we are going to get our line in standard form by subtracting 2x and then dividing by that leading coefficient of -1, which is in front of your y value. So if you do that correctly, you should get the equation y equals 2x minus 10. And again, that's from subtracting our 2x to the other side and then dividing by that leading coefficient of 1. So now that we have our parabola and line in their y equals form, we're going to take the two, we're going to set them equal to one another, and we are going to solve the quadratic equation that emerges. So here's our original setup. As always, get it equal to 0. And in the case of these, as I said, these will be factorable, which is a great thing to know. So at this point, this trinomial is factorable, creating factors of x minus 8 and x minus 2. We're going to t-chart and get each individual x value. Now here's the thing. In most cases, in standard quadratics, we would be done because these would be the roots. But we are looking for a little bit more than that. We're looking for the point of intersection. So what has to now be done is we are going to take each x value that we found and get a matching y value. To do so, we're going to plug these values into either equation. My recommendation, always use the line. It's the easier of the two. So if we start with the 8, we get 2 times 8 minus y equals 10. We're going to solve. And we see that we get a y value of positive 6. Meaning, we have the point of intersection 8, 6. For this parabola and this line, they have a point of intersection at 8, 6. We're going to do the same thing for the 2. So plug the 2 in for x and solve for y. So in this case, we get negative y equals positive 6. Divide both sides. And we get the other point of intersection at 2, negative 6. Again, this is a concept you guys have covered back in algebra. I know it's been a long time since you've probably seen it, but there it is. Or set them in standard form, set them equal to one another, and solve accordingly. It's all skills you know how to do. Just please remember, you're going to solve for that y value as well to find those matching points of intersection. All right? Now, algebraically, pretty straightforward. Graphically is actually an easier skill. So we had reviewed how to graph a parabola with our inequality work the other day. And basically what we're going to do is just graph the parabola, graph the line, and literally see where the two values or the two functions intersect one another. Please make sure, though, that you clearly state your points of intersection. Right? Without stating them, we're not showing what our true answer would be. So, to do one quickly, here is your parabola, here is your line. For the parabola, like we saw in class, we want to make sure that we go to our calculator, put everything into y equals accordingly. So here is our x squared minus our 2x minus 1. We're going to go to our table of values, and we're going to look for that window pattern that we had described the other day, which you guys can see on my calculator. So this will be the x and y table that I put on paper for the parabola. And again, we want to make sure that we're stating the table of values that we are using to create our parabola. So we're going to graph accordingly. All right, so once you guys plot your points for your parabola, you're going to connect them. Make sure you extend your parabola far enough so that whatever points of intersection exist, you are able to plot them and match them correctly. Now for the line, you guys can once again put this into your calculator, get a table of values and graph. Or if you remember from your algebra days of finding slope and intercept, you can graph the line based upon those two pieces of information. Again, if you don't remember that, that's okay. Just make sure that you graph your line appropriately, whether you use a table of values or whether you decide to use the slope and intercept method. But again, doing all this, plotting our points, we're going to connect as we go along. And actually, hopefully we see the two clear points of intersection after graphing these two together. So here are the 2 points. We're going to clearly state their values. So notice my point of intersection statement. We get a point of intersection at -1, 2, and the other at 4, 7. And we have solved that system graphically. So that's it, guys. As far as your entire lesson, it's a little bit of each. The algebraic solving, which is something you have seen before. Again, this is an algebra skill you learned years ago. Just refreshing it one more time because it is a popular type of question. And then graphically, again, whatever your approach, but the parabola is found from the calculator. The line can be found from the table of values as well, or by using your slope-intercept method that you had learned back in algebra. All right, so with that, guys, that concludes today's flip lesson, and it also concludes the entire unit for quadratics. Please make sure you complete your review sheet for this evening for Friday's test. Have a great day.